Hey everyone, and welcome. Let's just jump right in, shall we? We're going to tackle one of the coolest questions out there. How on earth do our computers, our phones, all our smart devices actually get what we're saying? It's time to pull back the curtain on the secret language of your computer.
I mean, really, stop and think about it for a second. You ask for directions. You dictate a text to a friend. You tell your speaker to play your favorite song. How does it get from the noise coming out of your mouth to actually doing the thing? It kind of feels like magic, right? But it's not. It's actually a brilliant step-by-step process.
And that's exactly what we're going to break down today. We're going to see how machines analyze our language by climbing this three-level ladder, starting with the tiniest pieces of words and going all the way up to the real meaning of a sentence. So let's start at the bottom rung. Okay, level 1 is all about something called morphology. And yeah, it's a fancy word, but the idea is super simple. It's just the study of how words are formed. Think of it like this. If language is a giant Lego castle, morphology is the study of the individual Lego bricks themselves. Now, you'd probably think the smallest piece is a word, right? Well, nope, we can actually go even smaller. The real fundamental building block is called a morpheme. This is the absolute smallest chunk of a language that still has its own meaning. You can't break it down any more than that. And here's a perfect example. Let's take the word unhappiness. You see, it's not just one thing, it's actually three distinct pieces of meaning working together. You've got which clearly means not. Then you have happy, that's the core idea, the emotion. And finally, you have ness, which is a little piece that means a state of being. So three morphemes, three little Lego bricks that all snap together to build one complex word. And these little morpheme bricks come in two main flavors. First, you have free morphemes. These are the cool independent ones like happy or cat. They can be a word all by themselves. But then you have bound morphemes, like or that nis from before. These guys are a bit clingy. They have to be attached to another word to mean anything. And get this, these morphemes can do two totally different jobs. The first is called derivational morphology. This is when adding a piece creates a whole new word, like when you take the adjective happy and turn it into the noun happiness. But the other job, inflectional morphology, just kind of tweaks a word for grammar. Think about adding an S to make book into books. It's still the same core word, just in a plural form. Okay, so we've got our Lego bricks, our morphemes and words. But you can't just throw them together randomly, right? You need the instruction manual. And that brings us up to level 2, syntax. This is the grammar, the set of rules that tells us how to assemble words into sentences that actually work. Now, the process of figuring this out is called syntactic analysis, or you'll hear this a lot, parsing. It's how a computer takes a jumble of words and finds the hidden blueprint. It figures out, okay, what's the subject, what's the verb, how do all these pieces connect to each other? All right, let's look at a real sentence. The gallbladder is surgically absent. I know, it sounds a little clinical, but for a computer that's just learning the ropes, it's a perfect, straightforward example for grammatical analysis. So the first thing the computer does is spot the main subject. In this case, it's the gallbladder. Linguists call this the noun phrase. It's the who or the what that the entire sentence is about. Easy enough. Then, of course, you've got the second part, what the subject is or what it's doing. Here, that's is surgically absent. And that's called the verb phrase. So by splitting the sentence into these two big chunks, the computer gets the basic structure. But, grammar isn't always this simple. Have a look at this sentence. I saw the man with a telescope. Grammatically, it's totally fine. Checks all the boxes. But it has a hidden problem, a really common problem called ambiguity. And this is the issue. The rules of grammar allow for two completely different meanings here. Was I looking through a telescope to see the man? Or did I see a man who just happened to be holding a telescope? How in the world does an AI figure out which one I meant? Well, it does something really clever. It plays the odds. By analyzing billions of sentences from books and the internet, the AI learns which sentence structures are way more common in the real world. So it figures, hey, it's about 85% more likely that the man had the telescope. It assigns a higher probability to that interpretation and just goes with the most likely meaning. Pretty smart, right? So we've built our words and we've put them together using the grammar rulebook. But there's one final, absolutely critical level. Does the sentence we built actually make any sense in the real world? This is level 3, semantics, the study of meaning itself. Check out this sentence. The boy eats a laptop. Now, according to the rules of syntax, This sentence is perfect. It has a noun phrase, the boy, and a verb phrase, eats a laptop. It's grammatically flawless. But we, as humans, know it's complete nonsense. This is where semantics kicks in. It's the reality check. So for an AI to get this, it has to understand this incredibly complex web of relationships between words. It needs to learn that happy and joyful are basically the same thing. It has to know that the bank by a river and a bank for your money are totally unrelated. And it has to grasp that a poodle is a type of dog. This deep knowledge is the key to unlocking true meaning.
Okay, I know, morphology, syntax, semantics, this all might seem a little academic, but really understanding this three-level ladder is the secret to understanding all the amazing AI that's woven into our lives every single day.
Seriously, this is the engine behind technologies we totally take for granted. Machine translation, yep, it's gotta understand all this to work. Speech recognition, you bet. Even something as simple as the grammar check in your word processor or a Google search is constantly running this deep kind of linguistic analysis in the background. So the big takeaway is this. Every single time you talk to your phone or your smart speaker, it is climbing this entire ladder of analysis, from the tiniest word parts, to the grammar, to the deep meaning, and it's doing it all in the blink of an eye. It's an incredible feat that turns your words into actions. Which leaves us with one last big question. We've seen how machines can deconstruct our language to figure out its structure and its meaning. As they get even better at this, maybe even understanding our intent or emotion, what's next? What's the next great challenge that we're going to turn this incredible power towards? It's definitely something to think about. Thanks for joining me.